Build a simple text search engine with TF-IDF. By the end, you will see a tiny search pipeline. You will understand how TF-IDF scores rank documents. You will get a minimal query function that returns ranked matches and a clear place to tune relevance. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. TF-IDF matters because it quantifies term importance for relevance. It boosts words that are common in one document but rare across the collection. The trade-off is memory and time to build the index for larger corpora, and exact TF-IDF is slower than approximate methods at scale. For a few thousand documents, you get high signal and predictable results. At a high level, TF-IDF multiplies how often a word appears in a document by how rare that word is across documents. It shines on short queries and clear vocabulary. It struggles with synonyms and phrase meaning, so you sometimes add n-grams or a different ranking model. We will build a tiny 3-sentence corpus, compute per document term counts, compute document rarity, rank documents for a query, and then return top results. First, we prepare the tiny corpus and inspect raw word counts. This snippet builds the tiny collection and shows which words dominate the first document. It creates a list called docs with 3 short sentences that act as our mini corpus. Each sentence is split into tokens by converting to lowercase and splitting on white space, so words match reliably. The code uses counter, which is a simple frequency tally that counts how many times each word appears in a document. The variable TF0 holds the counter for the first document, and most common returns high-frequency pairs in a stable order. Printing those pairs reveals the dominant words and their counts for the first text. Next, we compute document frequency and inverse document frequency to weight rare words. This snippet computes IDF values so rare words stand out as more informative. It first builds DF by counting in how many documents each token appears, rather than raw counts, which captures document frequency. Then it applies a smoothed inverse document frequency formula, using the logarithm from the math module, which reduces the impact of very rare words and avoids division by 0. Sorting the vocabulary by the strongest IDF values and then alphabetically keeps the output stable. The printed list shows which terms are rare across the tiny corpus and their IDF weights that will later multiply term frequencies. Now we rank documents for a sample query by summing TF-IDF contributions. This snippet shows how to score documents for a query by summing term frequency times IDF for each matching word. It defines a list Q for the query terms and uses a TFS list that holds a counter for each document, so lookups are fast. For every document, the code sums IDF of a tome multiplied by how often that term appears in that document. Sorting by descending score and then by document index gives a deterministic ranking when scores tie. The printed tuples show document indices paired with their TF-IDF match score, so you can see which documents best match the query phrase brown fox. Then we remove noise by filtering stop words and recomputing rarity. This snippet filters out a common stop word and recalculates document frequency and IDF to sharpen signals. It creates a set called stop with words that add little meaning for search and removes those tokens from the per document token lists. Rebuilding DF then recomputes how many documents contain each remaining word. The same smoothed IDF formula is applied so weights remain comparable. Sorting again surfaces the top rarity signals, and the printed pairs show which terms now carry the most weight. Removing noise, like the conjunction, and shifts important to more informative vocabulary. Finally, we run a top K TF-IDF search and return concise ranked results. This snippet performs a top K search using the TF-IDF scores and returns the best matching documents. The query queue holds the search terms, and TFS still provides quick access to per document term frequencies. For each document, the code sums IDF weighted term frequencies for the query words to get a relevant score. It then sorts documents by score and slices the list to the top K results. Increasing K returns more matches and may slightly increase latency. Decreasing K returns fewer results instantly. The printed tuples show which documents best match lazy dog and form a minimal usable search baseline. Recap: TF-IDF multiplies term frequency by inverse document frequency to surface informative words. Use it for small to medium collections and for interpretable fast relevance. One caveat is it ignores semantics and phrase structure, so it can miss synonyms and context. Next step: tune TF-IDF by adding n-grams to the tokens, or move to BM25 to improve ranking for longer queries. If practical IR and clear Python examples help you, subscribe and watch the rest of the search videos.